Hello, my name is Mir Kamal Rakimov. I'm here again to explain my code that was given to us in order to solve. There is a three problems, which is starts from problem 4 until problem 6. So I'm going to start from the problem 4. Problem 4 is basically the cycles. So what it says, like, create and draw graph 12 DAT as a directed graph. A cycle is a list of more vertices and edges, and so connected. Write a program to find all cycles. So what we doing, the first, we are importing our libraries. We are giving the vertices, and which was given by graph DAT12. So we are doing the edges, and here we are drawing this one, and we are iterating through the edges, and we are drawing this in the cycle form, because it was the part was called like cycles, so we are draw it in the cycle. So this is our result, which is very good in the Jupyter notebook by view. So we are doing the alternative way with the another edges, with this one. So this is the cycle form, is the another format, like with the much more edges, which was given by the DAT. So there is a find cycles our graph. So in this program, the find cycles function takes a graph represented as an edges is a list and returns as a list of cycles in a graph. The DFC function performs a depth first search starting from a given node, keeping track of the visited node, current path, everything. So there is our find cycle graph code which was written, and DFC. So we are keep tracking of the visited and passes, and which is true and not true. So we are making visited false if there is a node is false. So after that, we going through all the vertices from here, and we in the end we are returning the cycles. So the graph 12, we are creating the new variable which is called graph 12. So within the cycles and the find cycles graph, we are finding the cycles. So this is our answer for the fourth problem, which was write a program for finding cycles graph in 12. So the fifth problem is a computer shorts fast from the point P and point 6 to the 8 in the graph for an add distance. So this is our fifth problem. I will make it in all the separate files, but for visualization and for video I'm doing in the same Jupyter notebook. So in this case, we are also like taking these libraries as usual. I'm using network X and as NXE. I'm giving the vertices and edges at the same time, and I'm using the graph object class, as an object G, and after that I'm trying to draw as I used to do. So this is our graph is in simple form. So as it asked, so this is our first target, which is 1, 0, 8 and 999, and this is the 2 6 2 8 and 5 3 8, which is our target. So we are going to find the shortest path, so which is going to be this way, like straight line. So which is going to be this, and he's going to here, like, which is in the straight line, like almost straight line. So there's the continuation, which is we are going to check for the shortest path in the example. So like we are giving the start point and end point, like in this case. So in the end, like we are trying to PLT show all of the things like this one. So there is a problem 6. We have to create and draw graph 6. Make sure to add distance each edge, find the shortest path that starts at P 66 78 and visit cities 675 and 86. So in this case, we are doing in the points format. I'm doing in the point format, like I'm importing the network X and matplotlib, pyplotlib libraries, and I'm giving the points, and I'm creating the class as usual, and I am doing some calculations with using enumerate functions, and I'm using the shortest path with the using traveling salesman problem, which is a very bad by optimization if you use. So we are doing, and after that if we give, there is a some bunch error, but it's the error of the library, not our code's problem. So which is giving our key to the CMap, and in this case we are watching this one, like, which is a very complicated and which is not that understandable, this graph in this case, because it's also was same, like I mean so complex in this book, like as it given sixth one, like shortest travel, because it's very complex. It goes through all the things, all the complex, and because of some visualization it seems a little tedious. So in the last one we are writing our digextra, which was given in the project file, but we are overriding this code in order to make it much more easy to understand and easy to how can I say, easy to track, and make it explainable. So we are creating digextra, queue, distances, and visit, all of them we are following from here, and we are going to the queue inside of the queue, and after that we are going to each neighbor and wait in the graph, and we are doing the past, current node, everything in here in the reverse form, and we are giving our graph, example graph, and we are giving the start node and end node like as example, because we overrided this function which was given by the project file, and here we are printing all the results. So when I put this, like from A to E, the shortest path is the distance, which is 8. So it calculated according to our calculation, and which was overridden by the code. Thank you so much for attention.